Welcome back to the Pony Math Teacher. Our expectations are these notes, our notes to your future self. I'm taking a lot of videos today. So make sure you use twice the video's length. I'm going to try to keep it between 10 and 15 minutes. So reserve 20 to 30 minutes for you to process. Take your time, take a deep breath, breathe in and breathe out. Just close your eyes, be calm with it, and we'll keep moving on. And we have more resources on my website listed below. And I'm going to minimize. Okay, so dimensional analysis. So we just did proportions for 2 pages at dimensional analysis. I have 2 pages, but I'll probably just do 1 page of notes on it. The other page is just examples, which you can find online. And then after that, we'll move into percent of change with discount and tax and literal equations. All of these are ways to apply solving equations, which we're going to see later in our comprehension activity with our objective. So dimensional analysis, make sure it is labeled, and we will move it on. So page 13, dimensional analysis, which sounds so funky. So we're going to define it. Dimensional analysis. Okay, so this is the method using equivalent ratios, which is why we learned about those last lesson, so we can use it in this lesson. And I spelled equivalent. There you go. E-N-T. There you go. Equivalent ratios to convert units. So we're going to be changing from centimeters to inches and vice versa. So example is we are going to measure some things. So if you have a ruler around you in centimeters and inches, be preferable if you have those items. So length of pencil, we're going to do those first. So length of a pencil. And we're also going to have volume of a bottle. So it can be a bottle of anything. I think I was thinking of water originally, but it can be a bottle of anything. So length of pencil, what would that be in centimeters and what would that be in inches? Bottle, what would that be in liters and what would that be in ounces? Fluid ounces specifically, because this is a liquid. So writing those down, let's Google. No, I don't want to do that. I guess we'll use Brave, why not? Okay, I want to Google the length of a pencil, centimeters. Okay, we're going to go with 18 centimeters. So I'm going to then convert 18 centimeters to inches. So I'm going to write 7.087. We'll just round that up. And then volume of a bottle. Volume of water bottle. It's about 1 liter. And convert 1 liter to fluid ounces. 33.814. Okay, we're going to click Brave. My computer does not like Brave. It overheats a lot. Okay, so length of pencil, we're assuming is 18 centimeters, or we could write that as 7.087 or 87 thousandths inches. And then 1 liter for volume of a water bottle, or 33 and 814 10 thousandths. Yeah, hundreds, thousands, 10 thousandths. Or you could have picked whatever you had on your water bottle lid. So, or water bottle label. So just knowing that these are actually conversion factors, we could use these as a conversion factor. Instead, we're going to use smaller decimals, just because that way we don't have to have as big of numbers as 18 or 33, because those are really large. But let's define those. Conversion factors. And we're going to write a whole bunch of these. So these are specific equivalent ratios with units. And I'm going to write this in all caps. Each makes 1 Each makes 1. If we divided them, it would be 1 because they are equivalent. So we're going to write a bunch of them. And then we'll put them all in a bubble. So 2.54 centimeters is what we typically use to represent 1 inch. This is a conversion factor because 2.54 centimeters is the same as 1 inch. So if you divided them, you would end up with 1. These are all convenient names for 1. We could also write this as 1 inch divided by 2.54 centimeters. These are the same thing. They're both 1. So it doesn't matter if the inch is in the numerator or the denominator, as long as the centimeters is the same coefficient in the numerator or the denominator as well with it. Okay? So we could also write 1 ounce over 28.3495 grams. Or you could flip that if you wanted. Okay? So or, and finish that off. 1 foot with 0.3048 meters, or flip it, finish it off, 1,000 grams to 1 kilogram, or finish it off, 5,280 feet goes into 1 mile. Note that for meters it's just an M, miles is MI, milliliters would be M with a capital L. So make sure that you are writing the correct letters that you want for the correct unit. Or flip that, and then 1 kilometer goes to 0.621371 miles, or and then complete that. So I'm going to now put this in a big pink bubble because it's important and I might sneeze, so just an FYI. Okay. Alright, so we're going to do 2 examples, but we might do more since we have a little bit more room, but we'll see. Okay, so example 1, a new baby, I want to write it, I guess. Yeah, a new baby weighs 7.8 pounds. What does it weigh in kilograms? Because most of the world uses kilograms. We in America use pounds. So this is knowing that 1 kilogram is the same as 2.205 pounds. So you can approximately just multiply it by 2, but that doesn't, to get your kilograms into pounds, but that doesn't actually get it as more precise. The more decimal places you have, the more precise it is. It still won't ever be precise because 3 decimal places is not enough. They don't quite convert that cleanly. Alright, I'm going to use a pen just because it's thinner. So, I'm going to start with 7.8 pounds. They didn't give me any other unit, so I'm just going to put it over a 1, and that 1 has no unit. It's just a placeholder because I'm going to deal with numerators and denominators. Now, in order to get rid of this pound, because I want to change it to a kilogram, I'm going to have a pound in the denominator because a numerator divided by that denominator, if they're the same thing, they disappear. So my pounds are going to go away, but I want to change it into kilograms. Do I know a conversion factor that compares kilograms to pounds where it's an equivalent ratio? I do. They actually gave it to me in the problem. So because I know where my labels, my units should go, then I just put the numbers in their corresponding spots, and I'm going to get my calculator. Big zoom in on my hair, huh? It's so long. Never had it this long. So I'm going to do 7.8 and then divide by 2.205. So this is approximately 3.54 kilograms. Oop, I should have kept the approximately in there. I'll rewrite it. There we go. That's what we do. Woohoo! I'll put it up here. Okay, and then second example. Yeah, we'll do 3 examples. I'll do a long one on the bottom. So this is going to be reserved for example 3. Okay, example 2 is how many seconds in 2 days. So sometimes you're going to get questions for situations where we don't have a conversion factor listed above. I will use these for example 3, but sometimes it's just using your common knowledge. You all should know how many seconds are in a minute, 60. How many minutes are in an hour, 60. How many hours in a day, 24. All right. So we're going to be starting with 2 days. They haven't told us any other thing, so I'm going to have it over 1. And then I want to change days. I want to end in seconds, but do we know days to seconds? That's a conversion factor that we typically don't know. But like I said, we know seconds to minutes, minutes to hours, hours to days. So that's my path. I'm going to go backwards. So from days, again, if it's in the numerator, it has to then go in the denominator. From days, I'm going to go to hours. From hours, I'm going to change to minutes. From minutes, I'll change to seconds. You could combine some of these, but we know these. And you're using a calculator anyway for this, please do, because there's decimals galore in this stuff. So please use a calculator. So hours to days, I know there's 24 hours in one day, there's 60 minutes in 1 hour, and there's 60 seconds in 1 minute. You could do any conversion factor you wanted with these 2 variables as long as they were equivalent. So I could do 2 hours and 120 minutes. That would be okay. It's not simplified, but that's fine. Okay, so my days, hours, minutes, I end in seconds. Do this to make sure you're actually answering the question. It asked for seconds. I started with days. I've got that. Now let's just do a calculator. So I'm actually just dividing by 1. So I'm really only doing 2 times 24 times 60 times 60. So I know 48 times 60 times 60 equals, and this is an exact one, and then comma, and it's seconds. I do need the units. Boom. We got this. All right, example 3. I'm going to find a good one. Oh, good. There it is. All right, so our last one is going to be, I'll write it in brown, I guess. I want 75 meters per minute to kilometers per, no, I'm going to do miles per minute to kilometers per second. Yeah, that's a good one. Sure, why not? Okay, so I'm going to start with 75 miles over 1 minute. If it says per anything, per means that division. So now I'm going to change the miles, because that's distance, into kilometers, while also changing the minutes into seconds, because those are both time. So let's do the minutes first, because we know that one. So if minutes is in the denominator, I have to move it to the numerator, and I can go straight to seconds. I don't have to do any wishy-washy dancing around stuff. I can go straight to seconds. So minute, end in seconds. I'm going to circle it just so I can find it. And I have 60 seconds in 1 minute. Perfect. Time, done. Distance, miles to kilometers. Oh. Actually, let's go miles to meters. Let's just make it meters. I should change that to miles. Whatever. I'm doing this just so we have to do more steps. So we get more practice with it. Okay, so I'm with miles, and I want to change it to meters. So in our conversion factors, if you notice, I have a miles to feet and then a feet to meters. So I'm going to change my miles to feet. Then I can go from feet to meters, and that will end me. Okay, miles, feet. I'll end on meters per second. I will end with Yoda IB, and then I'll fill in my blanks. So miles to feet, 1 mile to 5,280 feet, and then 1 foot goes to 3048 meters. Perfect. Now on my calculator, I'm doing 75 times 5,280 times 3048, and then divide by 60. This is hundreds, thousands, thousands, 100,000s. Okay. So 75 times 5,280 times 0.3048, enter, and then divide by 60. Now I can avoid parentheses, and this is actually equals. It's still kind of approximately, though, just because we're using conversion factors that are approximate. And this is our units, is meters per second. So if you were traveling 75 miles per minute, whew, that's fast. Because we travel 75 miles per hour typically. 75 miles per minute, that's the same as going 2,011.68 meters per second. Whew, that's fast. Alright, so that ends our dimensional analysis. It's just using ratios and doing a bunch of multiplication and division. Objective. There we go. Nope. Comprehension questions. Write a brochure how to answer the following objective. So wait a couple more videos to actually do this, but see what you would need from this in order to complete this. Students will solve equations and their applications and proportions. You've already done that. Dimensional analysis, we just finished, and the rest are where we're going. So this comprehension question activity will stay up for the next 2 videos. All right. See you then. Have a great day.